All right, so we are back in the textbook after a lovely week of trig review, and we're going to talk about the unit circle. We're going to take this over 2 days. The notes video is going to be pretty long, so the problem set on the first day is going to be pretty short. And then day 2, I want you to spend longer on the problem set, work through everything that you see there. So, if we're going to talk about the unit circle today. So, this is one day if you have a printer, I strongly encourage you to use it because we are going to fill in a lot of information on this diagram called the unit circle, and it's going to be incredibly helpful if you have this printed out versus drawing your own. If you don't have a printer, take time to draw this neatly in your notes, and we're going to get to that. But if you need to pause the video, print out the attached PDF, the blank copy. If you don't have a printer, that's all right. Just make sure that you're spending time to make that diagram as neat as possible. All right, so in the unit circle is basically just a circle with radius 1. That's where the unit comes from, like unus in math. It's a circle with radius 1. And so if you remember from previous classes, the equation for this is just x squared plus y squared equals 1. And that equation is going to be helpful. And the point of why the unit circle is something that we care about, because obviously you probably have seen this equation before and you're like, okay, why are we going to spend a 20-minute video talking about the unit circle, is that each point on the unit circle it's a memory device. So mnemonic device or memory device for your trig values. So if you think about the table that I had you make, which was, okay, what's the sine of 60 degrees? What's the tangent of 30 degrees? What is the cosine of 45? The unit circle helps you memorize those plus dozens more, because one thing that you're going to be doing a lot of in the next couple chapters over the next couple weeks is you will be asked, okay, well, what is the exact value of not just the sine of 45 degrees, what's the sine of 135 degrees? What is the cosine of 270 degrees? These are all constants, just like with our special right triangles, and the unit circle helps us remember those. And we'll talk about more in the first place. We're going to just talk about the values right now so you can start memorizing and start using this trick as quickly as possible. So each terminal point on the circle, so a terminal point is just a point on the outside of the circle here. It can be a myriad of points, but the ones that we care about, these ones for the special right triangle values, so like 45, 60, more, all of these will come from the same numbers. So all angles that you have to memorize the trig values for of sine and cosine on this circle, but all the ones that you maybe noticed when you're filling out the table last week are going to be 0, 1/2, root 2 over 2, root 3 over 2, or 1. And then there's plus or minus. You're going to start having positives and negatives. If you want to use your calculator, you'll notice if you type in, cosine of 180 degrees, you're going to get a negative number. If you type in sine of 200 degrees, you're going to get a negative number. So there are definitely negative sines and cosines. We just aren't used to seeing them in word problems because it doesn't really make sense for us to have positives and negatives in terms of a triangle that we're looking at. But in terms of trig values, you can actually have positives and negatives. Now, in the unit circle over here, each of these corresponds to an angle. So if I'm going to look at this first point right here. And we label these based on the angles that they have. So the angle is going counterclockwise up from the positive x-axis. So what you're going to do is you're going to think about corresponding each of these points to an angle. So this is the smallest one I'm asking you to memorize. So this would be 30 degrees. Whoop. You also might label it in terms of the radians, and this is where radians are actually going to be really helpful. So this would be pi over 6 as a radian. 30 degrees, pi over 6, they're the same thing. The next one here, going up from the bottom here, you'll notice it's halfway through this quadrant, which is quadrant 1. This is 45 degrees, which is pi over 4 from the table. And then we have 60 degrees, which is pi over 3 for our next one. And as we come around to the top, this is 90 degrees here, which would be pi over 2. So again, if it's helpful at this point to keep labeling them not just with the radians but with the angles, that in degrees, that's fine. So you can have both. The radians are going to be really helpful though in this case. But if you want to do both, because I definitely know this is more familiar, and this hopefully makes sense, you're like, oh yeah, that's a 90 degree, that's a right angle here. Now, as I said, these keep going around. So in this case, this next one, we're still talking about 90 degrees plus, in this case, it's another 30 past. So the t value here is 2 pi over 3 in radians, or 120 degrees. Here we have 3 pi over 4, which would be 135 degrees. 5 pi over 6, which would be 150 degrees. And then again, we're coming round to the bottom again. And we've now gone halfway around the circle. So in terms of our degrees, which are easier just for us to visualize at this point, this is 180, which as we know is the same as pi. Now, you can pause the video if you want to just fill in from the bottom. I'm going to do this pretty quickly. If you want to fast forward, I am not going to talk through every single one of them slowly so that I can focus on writing them in. 7 pi over 6. This would be 5 pi over 4 radians. Let's see, 4 pi over 3. 3 pi over 2 here on the negative y-axis. 5 pi over 3. 7 pi over 4. 11 pi over 6. And then we come back around to here, and here's the important idea here, is that this point on the positive x-axis could be 0, could be 2 pi, which again is also equal to 360 degrees, could be 4 pi, and this is the idea, is each of these points align all the way through with many numbers. So if I wanted to use this point, here, this is 90 degrees, this is pi over 2, it's also 360 degrees plus another 90. So this would also be 450 degrees. There's also negative. These are all positives. If I wanted to go negative 45 degrees, that's just going clockwise. That's going the other way. So you could say that this point here is also equal to negative pi over 4, negative 45 degrees. So you have positive and negative values. Now, the reason that I say that it's important to remember radians is radians are helpful for the reference number. So visually, we've got our quadrants here, quadrant 1, 2, 3, and 4. And what you'll maybe notice here is that in each quadrant, you have one each with the same denominator. So you have pi over 6, pi over 4, pi over 3, pi over 2. Then we have 3, 4, 6. This would be pi by itself. 6, 4, 3. 3, 4, 6. So those are the only denominators we really care about. And those denominators tell you where the point is on the unit circle, which is a really helpful memory device. Because what you're eventually going to use this unit circle for when we fill in the ordered pairs is, again, they tell you the sine and cosine of all these angles if you can remember them. I don't actually have all these memorized, but I know that if I see something with a certain denominator, I can figure out what the values are. And so the reference number, which is t with a line over it, is just looking at the denominator. So if I'm looking over here, the reference number is pi over 4, because we're just really caring about that k denominator. This 5 pi over 4 here, this point would have the same reference number, same denominator. And so what you'll notice is that all the pi over 4s are directly in the middle here. All the pi's over 6s are what I think of as close to the x-axis. So we have a set of points that are closer to the y-axis here. They all have pi over 3. The pi over 6 is close to the x-axis. And the pi over 4s are right down the middle. So I'm just going to start by wherever the reference number is, where it is pi by itself, pi over 1, you could think about it. Those are these points, and they are on, so these are on the x-axis. So anything that is pi over something, and if it's on the x-axis, that means that we're talking about the x value is plus or minus 1, and the y value is 0. Because remember, this is a unit circle. It has a radius of 1. So if I'm looking at this point here, this would be 1, 0. The point here is negative 1, 0. So any multiple of pi, any multiple of 180. If I am looking at a reference number with pi over 6, so those ones, as I said, are near the x-axis. So if I ever see, oh, what's the cosine of pi over 6, cosine of negative, 5 pi over 6, I know on my unit circle that those are these ones that are near, they're close to the x-axis. And what that tells me is, remember, these numbers here are my only possibilities. Near the x-axis, that means that the x values, so the x values along here are longer, they're close to 1. If you think about, these are the x values here for those pi over 6 points. Those are going to be your next biggest number. So the biggest number on the circle is 1, because that's the radius. Your closest x value after that is root 3 over 2. Because remember I said these are the only numbers that show up. If you think about the table that we made last week. So the x values for all these pi over 6 points are root 3 over 2. And then the y values for these points are your smaller numbers. So they are always going to be in these, what I think of as a matched pair. So if one's a 0, the other one's a 1. If one is a 1/2, the other one is a root 3 over 2. Because one's got to be big, one's got to be small, or they can both be the same. So in this case, your x value, if it's pi over 6, is always going to be plus or minus root 3 over 2, plus or minus 1 over 2. If your reference number is pi over 4, that means that it's the middle of your quadrant. Quadrant 1, quadrant 2, quadrant 3. So in that case, they're both going to be plus or minus root 2 over 2. So if you want to remember sine or cosine of any multiple of 45 degrees, that's not a simplifiable multiple. It's going to have sine and cosine root 2 over 2 plus or minus. And we'll talk about exactly how this mnemonic works in our next lesson. For now, it's just about getting it written down and doing your best to memorize it. Reference number pi over 3, that's going to be near the y-axis. So what that means in this case, if you've got your pi over 4, you've got your equal root 2 over 2 near the x near the y-axis, you've got your next set of values, which is plus or minus 1/2 for the x value, plus or minus √3. Whoop. √3 over 2. And then lastly, if you have a reference number, a denominator of 2, that means that it's on the y-axis. And so that means that your x value is 0, because that's what it means to be on the y-axis, and plus or minus 1. So, a lot of information there. If you want to, I won't not recommend it. If it's helpful, actually write in the ordered pairs for each of these points. I know some students do that. Don't feel like you have to. But here you're like, okay, that's both positive and so on. So let's use some of these problems that you're going to have. Now, number 1 and some of your homework for this first day are going to be relatively straightforward. So like number 1, a point on the unit circle has the point 4/5 in quadrant 4. Find the missing y value. So we could just use our equation here. X squared plus y squared is equal to 1. I'm going to plug in 4/5. So 4 over 5 for x plus y squared is equal to 1. Since 16 over 25 is equal to plus y squared is equal to 1. Subtract from both sides. We end up with y squared is equal to 9/25. And here's where the quadrant part's important. That means y is equal to plus or minus √3 over 5. Now, since it's in quadrant 4, that means that the x value is positive, as we see here, but the y value is negative, because we're looking down here in quadrant 4. So that means that our y value must be the negative 3 over 5. Now, looking at the rules that we have here for terminal points, I'm jumping around a little bit, I know I am. Number 3, find the terminal point for pi over 3. So if I'm looking at pi over 3 here, I can say, all right, this is the 60 degree, this is pi over 3. I know these are my numbers, I know these are my rules. So pi over 3 has an x value that's positive, and it's going to be 1/2 because it's a shorter x value and a longer y value, which means that we are going to have positive 1/2 positive √3 over 2. Because remember, those are the only numbers that are going to be asked for in terms of your memorizing. Find the reference number and terminal point for 5 pi over 2. So the reference number, again, is just based on the denominator. And 5 pi over 2, you'll notice, isn't on here, because 5 pi over 2 is equal to, I can think of this as 2.5 pi. 5 over 2, 2.5. And remember, 2 pi is the full circle, and then you have another half that this is going. So 2 pi takes us around the unit circle, back to our beginning. Another half then is up here. So this problem is this t value is the exact same as pi over 2. Since it had reference number pi over 2, it could have been 90 degrees up at the top, or it could have been 3 pi over 2 here. Since it's pi over 2, that's the positive, so the terminal point, when it asks for a point, it's asking for an xy. That means it's got 0 for x and positive 1 here. So again, I know the unit circle has a lot of information on it. I really do recommend writing down the reference numbers and internalizing the ideas that you're only using these 5 numbers here. And if you're going to use numbers other than that, you can plug it into the equation because I will always give you one. Going into next week, I'll talk about how this connects more with trigonometry. Let me know what questions you have, nominate them in the form attached, and I would look forward to talking to a lot of you about the unit circle.